Hello, morning, evening, afternoon, usual greeting. Hope everyone's having a pleasant weekend. I will first off apologise that over the weekend I have picked up a cold, so I sound even more annoying than I probably normally do. So I do apologise if there's lots of coughing and spluttering and nose blowing. I'm feeling pretty rotten, but banged down some paracetamol. Got some water. We're gonna see what we can do today. It might not be my brightest, but everyone knows that the surefire cure for a cold is C++. There is no two ways about it. I believe it has been blind tested and peer reviewed in a medical journal, so at least we've got that going for us. Usual people rolling in, which is nice to see. So hello Beef, Mr. Bob Locks, Robo, Jason, good to see you as usual. I'm sure a few new people have come in. Thank you. Do get involved in the chat. It's always nice to get involved. It's always nice to chat with you guys. I have a dual chat system set up, so Twitch or YouTube doesn't really matter. It should all appear on my second monitor. So Greco, thank you for the little Pokemon emoji. I appreciate it. So I think first of all what we want to do is kind of go through a little bit of a game plan of what the next steps are, because we've got triangle rendering, so we're at least 80% of the way there. So in my mind, what's kind of the game plan is we need to do transformation, which includes some maths and a camera. Because I know we're all desperate to get to Hello Cube, but Hello Cube is kind of meaningless without the ability to kind of move it around, because it will just look like a square. So kind of need to do that. And then once we've got that, we need to sort of improve the rendering in that at the moment the renderer just has hard-coded an object. So this basically means we need to kind of add a scene, and then from there we also need to do index or rendering with indices. And that also means I want to improve the current OpenGL to use DSA, because I want to try sticking like the vertex data and the index data into one buffer using name buffers, that kind of good stuff, because I think that'd be kind of fun. And then from there, so once we can add basically any cubes we want to the screen, we can then kind of look to doing something a little bit more fun, like HDR, tone mapping, and gamma correction. And then I'd like to have a go at maybe doing, and then these are kind of in no particular order after this: SSAO, no, what do I want? Anti-aliasing, and I'd like to try doing screen space reflection, and then I guess something like game ? So that's kind of the rough plan. I think stuff like object mesh loading, that will fit in here somewhere around the improved rendering. We'll put mesh loading here, I guess, just in case we need it. My kind of vision for the game is going to be largely just rendering cubes, because it's kind of easier. I don't know if we'll be getting to rendering pipelines today, because I think today we need to really focus on trying to get a camera into this so we can actually see stuff moving around in 3D space, and then we can start adding multiple things. So I might do mesh loading just because it is kind of interesting. I'm not sure how much we'll need it, so that's kind of, I'm going to put like question mark there. It might be something fun to look at. But yeah, okay. So really, this is the plan. Well, this is the plan for today. It is subject to change at the end of every stream. So what we've got at the moment is the renderer. So at the moment, the renderer has a single hard-coded mesh and a single, you give it a material, and then it just draws that. So, and that's what we saw earlier. It's just the triangle. It has 3 vertices. The mesh itself is just a hard-coded set of vertices. So what I really want to be able to do is, and I know it's not particularly exciting, but I would like to be able to have this triangle move via a transformation. So we're going to have to do some vectors, we're going to have to do some matrices, a bit of linear algebra. That's what I kind of want to start building out today. We need to build out a camera class. This is quite, we'll see where we get to for time. It's quite ambitious, but I'm going to try and get that today. I'm not planning on doing alpha colors because rendering transparency is an absolute nightmare. It involves you having to sort of sort everything, render back to front. The sort of rough idea for games I have don't involve transparency, so I guess what I'm trying to say is I do want to make a game with this rather than an engine. Everything we do should be in service of getting to a game, so I don't want to write any code that is not needed for that. So we'll see where it goes. So apologies if it's too late for you. These are all available on YouTube afterwards, so you can always catch up afterwards. So I think the first thing to do is kind of make this a little bit clearer what's going on. And so we're going to want source vector 3.hpp, and in this, so it'll be pragma once namespace game, and then struct vector 3 float x, float y, float z, and that's kind of all we really need to start with. Yeah, it is 2008 for me. So this is kind of what we really need to start with for a vector class. Again, we could go through and start building out all the functionality, addition, subtraction, normalization, magnitudes, lengths, blah, 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 but we don't need it yet. So I'm not gonna do it. So I'm just gonna keep it simple. This is kind of more of a philosophical point for me. I guess it's more of a personal preference. If I have an object that just contains public data, then for me that should be a struct. As soon as it has to have like members or private internals, then for me that becomes a class. That's in my mind the distinction. Obviously the actual language distinction is just the default access modifier. So we'll keep this as a struct, but if we start adding methods to this, I might change that to a class, just because that's in my mind how I think about these things. So I don't understand what's the problem with rendering to multiple buffers and compositing at the end. Yeah, I mean, in the context of what, like, that is definitely something we'll end up doing, because we're going to want to do ambient occlusion, which involves doing that, or bloom, so that definitely involves doing rendering to multiple buffers and compositing them. I was talking more in terms of, like, if your object within the world has transparency, you have to render the thing behind it first, and then when you render the thing on top, that's when you have to, because you then have to do blending, and that's just like a lot of work that I don't really see any need for at the moment. Will the vector maths be external to the vector class? And yes, so I think if we need like additional, like the operator overloading, I'm just going to do those as free methods, because this is all public, so there's no need to not do those. And then you get some nice properties, like you can then do it with integers and stuff, and use like the special like implicit casting, which we'll see. The only kind of steady, don't know what that was. The only thing I will do for a struct is potentially, do I want to do constructors, or do I just want to leave it? I guess I'll just leave it for the moment, because we can use the aggregate initializer for what we need. So I think that might work for us. Yeah, there's no point having methods if not needed. I mean, it's kind of, again, it's philosophical. It doesn't really matter, because it's all going to drive us through to the end anyway. And then from here, I'm just going to do VS source game. Again, if anyone joining, apologies if I sound a bit grotty. It's because I am. Color.hpp. Pragma once. No space. Game, and then again exactly the same thing. Struct color. Nope, absolutely not. That is 100% not what I wanted. And then float R, float G, float B. Again, I'm ignoring alpha for the moment because I don't need it. Yeah, unfortunately, you have to put up with the British spelling of everything, because it's my code and that's the way I choose to spell it. I think color will probably be the main one. I think, unless we have to write specialize or something like that. Okay, right. So now we can have Can't open file for writing, no such file. What have I... Ooh, I've made a boo-boo. Right, okay, fine. Let's just yank that, and then we'll do vs source color.hpp, and then we'll put that in there, get rid of that, and then open that up. Okay, nice. Okay, so now what we can do is, again, source, okay, source vertex data.hpp. HPP. Oh, sorry, my brain is not with it today. I'm going to stick with .h. It's because someone was talking about HPPs the other day, and I'm... center. Yes, another good one. Silence the damn keyboard. You'll retain more non-coders and me longer. I cannot silence. The keyboard is exactly as loud as it is. I do apologise. Yeah, I've kind of stuck with H now, and I'm going to keep going with it. So I've labelled other files HPP. I'm going to try and keep consistent, and I've chosen H because in my mind it doesn't actually make any difference to the compiler. I've heard, some people have said it like compilers do treat them differently, but I'm yet to sort of find anything that actually kind of I'm yet to see that for myself. Thank you, Foss Unleashed, for coming over from YouTube. It's great to have you here. I don't have aesthetic clicker keys. I don't know what that means. Again, I'm sorry. So we got vector 3. Oh, I do. Well done. And color. I'll fix that in a minute. Move source vector source vector. And then I can do vertex, nope, vector 3 position, and color. Okay. Oh my goodness. If you thought my typing was bad normally, you've yet to see this. What's it? Man, have I really gone on a mad one today? We all make mistakes. Okay, right, so now I've got a vertex data, which I think better encapsulates what we're doing. So now we can go back to the mesh class, and then we can basically just change this to, I know static doesn't technically mean add anything here, I just a habit of typing it. Vertex data, and then this will be a const expr of game vertex data. And now I'm hoping I can just do something like, let's see, it's going to be every third one. And then it's going to be like that. Okay, let's remove these random comments that have crept in somewhere. And then hopefully the formatter will at least let me know where I've gone wrong. Excess elements in... now I need to group these because they are vertex datas. Okay, so now I'm going to have to add all the initializers, isn't it? So this is dot position equals that, and then this is going to be, so if we can line these up and get Vim to help us out a little bit, this is going to be dot color equals that, and then I dot x equals dot y equals, and then I dot z equals, and then again let's just line these up. We can do I dot r equals dot g equals I dot b equals. And then it doesn't like it, so I made a mistake somewhere. I don't think I'm missing the X initialize. I'm sure someone can see this and I can't. How much does it bother me if something doesn't line up with formatting? Almost 0, as long as it's still legible. If the formatter does something weird, so formatter really doesn't like ranges, and that does annoy me because then I find it actually impacts the readability. For stuff like this, at a glance, I can still probably figure out what's going on. Static context for a game vertex data array equals that, and then I've got. I'm really trying to see where I've gone wrong here. Yeah, it's just ranges. Yeah, the formatter really doesn't. The Clang format really. I think there's a bug. I think it's actually a bug in it. I think there's even a bug on their GitHub which they've just not fixed yet. You're missing the name. The name of what? Sorry, if you. Oh. Yeah, you're that'll do it. I'll tell you, I'm gonna all my mistakes today, I'm gonna blame on the cold. And then when I'm over it, I don't know what excuse I'll have. Okay, so we're still doing that. Still at the positions, still at the colours. Still going good. So what main? So we still got our hard-coded shaders. I need to add in resource management at some point so we can actually load these from a file. That might be, if we've got a bit of time at the end of the day today, I might do that. This is probably something I'll just do at the end of a stream. Hot chocolate. I mean, I had a supermarket branded Lemsip earlier. How does it? So that's a really good question. So how does what we just did compare to floats? I'm happy to take the time to kind of go through these questions. It is effectively the same. We laid out the same in memory, but this I feel provides more semantics. So it's obvious, like it's a natural new type in the type system. So it has conceptually. Before you just had a whole bag of floats, right? And you would have to know that each array of 6, like out of each block of 6, the first 3 was a position and the second 3 was the color. Now you've effectively given a name to those things through the type system, and I think that just makes it a lot clearer what's going on. So I can look at this and I can be like, oh yeah, okay, this vertex is minus, at these positions here, and this color. So I think it almost certainly gets compiled to exactly the same thing. Okay, so back to main. Someone said something. I was going to file watch the system for auto update models. Maybe, unless I need it, I'm not going to do it because I think it's very easy to kind of get carried away adding loads and loads of features that you don't actually need. So I'm just going to go with at the moment I don't need to load a resource, so I haven't. So what we want to do is, in the first instance here, we just want to be able to provide a transformation matrix to the vertex shader, which will just transform all the vertices. I'm not worried about projections. I'm not worried about views and cameras. In the first instance, we just want to be able to give a transformation matrix to this code and then wire that up so it works and do all the maths behind it. And then from there, we can kind of build out all the other gubbins that we need. So if anyone... so let me just check my notes on this, because where's the line I need? So here we go. Right. So to start with, I'm going to use a uniform mat4 transform. So a uniform is just a way of providing data to the to one of the shader programs. It's kind of fixed for every invocation of the shader across that model, but it's just a way of providing additional data to it. Now, I'm not sure whether this is like the best or the most modern way of doing it. I will probably switch everything to use what's called a UBO, or a uniform buffer object, in the future, but again, for now, just to get things going, I'm just going to keep it easy, and we're just going to basically smash 16 floats into the shader and then use it. I thought we were going to use v3y mat4 then. So v3 is a vector is a 3D vector, so x, y, z. Mat4 is a 4x4 matrix, which is how you represent transformations in like 3D space. I'll kind of go through some of the maths as we go through it, but it's basically, this is the way you represent a transformation. You can translate by a vector and encode that in a matrix, if that makes sense, and we'll kind of look at that in a second. So the .member name declaration, aggregate initialization, I think that came in 17 or 20. I know C's had it forever, and there's actually some subtle differences between C and C++. When you do it in C++, you have to initialize the members in the order that they're declared, whereas C doesn't care. So there's some, there are a few differences between the two. So C plus 20, yeah. So yeah, it took a while to catch up. Something about I already have the viewer requirements and just getting the stream time up. Yeah, so I'm also trying to get into the Twitch affiliate program, and I'm as far as I can tell, I'm 2 streams away from it, so which is exciting. So today and Wednesday, we'll see how we get there. The sweet giveaway, I'm afraid, is it's just the friends we make along the way. I'm afraid there's no prizes other than that. Okay, so what we can do is we can just do transform times this. Obviously, I still need to give it the transformation. So that's what we'll start to do now. So let's do source matrix4.h, get it right that time. Paragraph once. Namespace game, and then definitely have a class this time. Matrix4. You could do 4x4, 4x3, you can call it whatever you want. I'm not planning on having a load of matrix classes, so I'm just going to use that. I want to transform in the vertex shader, right? Because the fragment shader just paints the pixels that it knows exists from the previous stage. So I'm pretty sure the transformation goes in the vertex shader. Oh, I did the multiplication. Oh, someone telling me I did it wrong. Sorry. No, I'm pretty sure it's in the vertex shader. I've made a mistake. Oh, right. Haha, good one. Thank you. I'm glad someone's paying attention. I imagine I'm hoping the stream, although I'm not feeling 100%, doesn't discourage people from showing up in the future, and I might be a little bit more on my game. You appreciated the Sims 2 video. Thank you very much. I'm glad you enjoyed it. It's doing pretty well at the moment. It's coming up to 250,000 views, which is pretty good. Yeah, cool. Okay, right. So and then public and private, and then this will have stood array float 16, and that'll be, I don't know, elements. So matrix just stores, so 4x4 matrix, 4x4 is 16, just stores 16 floats. That's how you represent it. Yeah, I think someone's answered the question about the open source. I'm still undecided. I might release it. I'm not sure yet. Again, I think part of this is for people's is to kind of, as almost like an educational resource. So it might be useful for me to release it, but I'm not done it yet. So OpenGL is column major, as in the shaders, which is I think you can kind of go back and forth on this a lot, right? Like it's, you read all these articles, like some people say it's just a convention, blah, 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 don't have to worry about it as long as you put things in the right place, blah, blah, blah. But I believe OpenGL does do it in column major order. The way I like to think about it is, in fact, I looked this up earlier, is just like knowing the the indices in that matrix where OpenGL expects something, and then you can kind of almost forget about it. So there's a good Wikipedia Stack Overflow article here, someone asking like exactly this, because I knew this would come up, and then it's just like the translation component occupies the 13th, 14th, and 15th elements if you index them from 1, which is strange. So that's kind of how I think about it, is just like within the matrix, there are certain things that go in there. If anyone wants a better resource on Learn OpenGL than what I'm talking about on OpenGL, then learnopengl.com is a really good resource. I use it a lot. I'm sure it's almost like canonical at this point. But they've got stuff like this. So here you can see the translation here. Like it just goes in these elements. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you stick the translation element in these indices here and then give it to OpenGL, it should just work. But yeah, great resource. So I think we can make a lot of this is just like just sort of array data manipulation. So I think we can probably make a lot of this const expra. Elements. And then from here, so the identity, so if anyone's not done any linear algebra before or not done it for a while, the identity matrix is just a matrix that has no effect when you multiply by it. So it's what's called an identity, and that is just like ones down the leading diagonal. And again, it doesn't matter if it's column major or row major, those ones will always be in the same index. Why are projection matrices 4x4 or 4x2? So they're 4x4 because the whole thing works in what's called homogeneous coordinates. It kind of just... It basically just makes the maths work because you can bundle multiple transformations easier into a 4x4 matrix. Doesn't const expr slow down compile time? Why use it so much? I would always trade off like a one-off compile time cost for an improvement in runtime, which will happen every time you run it. But that's just personally for me. And also, like for the size of the thing we're building, it's going to build pretty quick. So 1.0 f, 1.0 f. Oh no, already off. F, 1.0 f, 1.0 f. Let's see if we can just and then there's noughts, and then do R1, and then dots. I hope you can see here it's the leading diagonals. This is all going to disappear. Yep, thank you for Clang format. Appreciate it. Get those in line. You don't actually have to have that last 0, but I prefer it. And then, so again, you can think of this class as just an abstraction over an array, right? So it really is just designed there to kind of, this is an implementation detail. This conceptually represents a matrix and the operations that we want to do on it, which we'll add to as we need to. The fact that it's kind of backed by 16 floats is conceptually irrelevant to the class design, right? I want to be able to say, oh, give me a translation matrix or a projection matrix. However, at some point the real world kind of comes crashing in, and we do need to get the actual byte represent, or the float representation of that, because we need to stuff that into OpenGL. So there's a couple of ways you can do this. You could return a copy of this, you could return a const reference to this. What I want to do is return a const span to this. We're going to call it like data, I guess. Const I think that can also be const expr. I'll fix these errors in a second because it's just a quirk of my setup. But like what I want to do is basically provide a read-only view onto these bits of data. You could make it writable. But that's just not the class design I want. I want to kind of prevent accidental, like I don't want people, and by people I mean me, accidentally setting random elements, like arbitrary elements in the matrix. I want people to be able to say, here's a translation matrix, here's a scale matrix, multiply them together. I want to talk in terms of like the mathematical language, and this is just like a way of getting that raw data out. MD span's not very well implemented yet. What I really want is Linaug, which is, again, it's coming in. That's my password manager. Nearly threw that there. We're getting this, which is based on BLAS in C++26, and this has stuff like vector to norm, matrix from norm. Has a whole load of stuff in here, which is going to be, and that, switching between the major, column major, and row major stuff. This is what I want, and this works quite well with MDSpan, but like we're not there yet. So it might be fun when that starts getting implemented to really refactor some of this, because I'm going to assume that whoever's implementing the standardized linear algebra code is probably better at it than I am. I'm not on Linux, I'm on Windows, but I use WSL and then I cross-compile for Windows because I prefer the Linux tooling. So hopefully that question comes up a lot, and I think it's good that question comes up a lot because it means there's new people here, which I think is great, so welcome. I'm always happy to answer that question. So hopefully this will fix my errors in a minute, and maybe not. Okay, right, so I've no... Why would I have no personal desire to dual boot because I just get everything I want all in one without having to switch between boots, right? WSL is pretty good. So that's why I don't bother with dual booting. Okay, so now we need to get the go back to the renderer. So we're gonna have a... Actually, no, sorry. Get that in a minute. Matrix. Let's bring in our vector class. I don't know why this is... Oh, because I've not built it yet, that's why. When we include this file and it actually gets built via translation unit, then all these errors will disappear because my tooling will kind of catch up with it. It's just a quirk of being only in a header. Okay, right. So I guess we actually need a way of constructing this from a vector. So if we const vector3, we'll call this translation. So if we give it a vector3, we're going to say, oh, I want a matrix that represents that. And this is basically going to be the same as this, but we need to make sure we update the specific elements, which I had up and now I've lost. Bear with me 1 second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Translation dot ry rz. So that should be all we need. So in theory, yep, we should be able to now create a translation matrix. Create a matrix which represents a translation in 3D space. Someone's saying use the square bracket operator, the index operator. Could also do that, but then I don't. At the moment, I don't need access to individual elements of the matrix, nor do I want... I know you don't have to do it, but nor do I want to provide write access to that. I basically just say, here is a bounded view, read-only view over the data, like non-owning. What have I missed? Ah, thank you. Nailed it. Like, there's also, but I think it's worth pointing out, there's a million ways of doing all this, and this is just the way that I've chosen to do it based on like my previous experience and what I think is going to work. Obviously, if you're going to do this for reals, you should just use GLM or an engine. But if you're kind of interested in more of the mechanics of like how do you actually, store transformations into a bunch of floats and get that over to the graphics card, then that's why we're kind of going through it. I try to avoid const members because that has an impact on your class's design. Your class suddenly becomes non-copyable, right? Because you can't overwrite that member. So it has actually implications on how the class can be used if you have const members. So I tend to avoid them where possible. I don't think this wants data because I think the language has deduction guides to implicitly construct the span from built-in types. Oh god, what happened to a stud auto? You can tell I'm really not with it today. I do apologise. Good spot. Is it good? So, this is a great question. Is it good sense to have a getter and setter for private members? So, personally for me, if you're having a getter and setter which simply does the getting and the setting, I would argue that should just be a public member. Like, all you've done is create more typing for yourself. You're providing the same API to someone just through more typing. Now, the pro for getter and setter is that you can add logging, you can set breakpoints, you can kind of, it provides an in to your class. For me personally, I would, if I needed to have that level of control, I would just set a hardware breakpoint on the memory and just get the debugger to stop on that. So personally for me, I would say that if you are writing a getter and setter which provides no other value other than just the getting and the setting, just make those public. But you're kind of free to make your own decisions, yourself. What I would say is if you want your class to be immutable, then providing just a getter and no setter with private members is, I think, is an excellent design choice, because you've now provided no way for a user to kind of set that data. But then again, I think in the C++ core guidelines it actually says if you're writing getters and setters, you should just make them public. Anyway. But good question. That is all I can really offer, and this is my opinion and experience, and you're obviously free to disagree with me, which is absolutely fine. So let's bring in our matrix class. Let's bring in our vector class. Let's create I'm just gonna just create it directly in here. Static transform static auto transform equals matrix 4, and then inside here we'll have a vector3 dot x equals, so I want to move it to the right slightly, because again we're just in effectively, I guess, what is it, normalized device coordinates. Like the whole screen is just like 0 to 1, so because we don't have a view, we don't have a projection, our entire world is kind of constrained to a very small range of values. So let's just move this along by a small amount. Static const expra auto z equals dot. I will C++, yes, C++, 20 brings format and 23 brings print ln, and I think print was also in 23. I can't remember if print ln definitely came in 23, but I can't remember. Yes, -1 to 1 for NDC, or at least for OpenGL, because I think NDC is kind of specific, because doesn't Metal and DirectX have like a shallower Z NDC, I think. But yeah, we're getting there. Maybe this might be a little bit more talky and a little less codey this week, but still got 100 people here, so I hope you're enjoying it. Thank you very much for coming along, those you are, to watch me splutter and cough and sniff my way through some C++. Again, for the 13 people on Twitch, I appreciate you being here. Do use the chat. I can see it. Yes, thanks, Steve. Not standardized. I appreciate that, because I remember when I wrote my first engine, which was OpenGL, because I was on a Mac, and then I was like, oh, OpenGL is deprecated. I need to switch to Metal, and then I was like, oh, none of my things display because the NDC has changed. I had to have a specific matrix to an additional transformation matrix. I had to apply to everything to handle that. We're not talking about Steve Valeray today. That's not on the cards, I'm afraid. I appreciate everyone who's now on Twitch. Thank you, Vinzez, for becoming a member. Much appreciated. Glad to have you here. Right, okay, so I can use an OpenGL function to get the location of the uniform, which basically gives you a special handle back to tell OpenGL, oh, hey, here is where I need you to write that data. So that will be GL uniform location. So given a program and then a name, it will get you a GL int, which is the location of the uniform variable. So that will allow us to write to it. So as we know, or you know if you've been here before, I have taken it upon myself to go through the horror of manually resolving all my own OpenGL functions. So I now need to do OpenGL get uniform location proc, and that will be GL get uniform location. So that should resolve that and allow us to use it. Yes, we've met some, thanks MediaBots, so comment from Twitch. This has been mentioned before. These all look like Welsh town names, which I find absolutely hilarious. Okay, right, so we've got the program, so then we need to use, there's a whole bunch of, well, actually, no, sorry, let's take a step back, let's actually call this first. So const auto transform uniform equals, what do I call it, GL get uniform location, and this will take our program, I think, so that's the material.native handle, and that will be transform. Again, we can make this a bit more generic in the future. At the moment I'm just kind of hard coding it in the render loop just to get us going, because I just feel like you can kind of get stuck in analysis paralysis with these things. Think, oh, I need to abstract this, I need to abstract this, and before you know it, you've not actually achieved anything. Yep, sorry, I got it. I even spotted it myself that time, but thank you for calling it out. I think what I've come to the conclusion is if I'm typing something and then out the corner of my eye I just see a flurry of chat messages, it normally means I've got a typo or I've said something outrageous and not backed it with any sort of evidence. No, you've not missed a lot. We're just building out transformations today. We want to try and get to a proper 3D world where we can then finally render the cube that I know everyone is so desperate to get to, but I feel to do a cube justice, it needs to exist within a proper 3D world. That's actually a good point. After improve the rendering, we will need to do, before we need to do this, need to do lights. Just keeping a little track of things myself. Yeah, depth testing will just come with when we go to render like more than one triangle and realize it doesn't work. So then, basically, when you want to transfer data to a uniform by name, so there's a thing in OpenGL called UBO, or Uniform Buffer Object, and that basically allows you to define a struct within the shader, and then you define that struct with the whole load of padding misery in your C++ code, and then you can literally just like kind of mem copy that in. When you're doing it via this way, you have to use the specific GL uniform function that corresponds to the thing that you want to copy in. So for us, this will be one of the matrix ones. Matrix 4, I think it's matrix 4FV. I think that's what it is. I'll double check my notes. Matrix 4FV. Okay, right. So GL, let's just put in the next Welsh town name. GL uniform matrix 4FV proc and GL uniform. Do I actually have this? Nope. GL uniform matrix 4FV. Right, nailed it. A pleasant town in the shadow of the Brecons. Amazing. If I talked to Twitch about partnership, they're usually fine with low numbers on here. If you have a big YouTube channel, would enable bits donation. So I'm nearly, we were discussing this earlier, I'm like 2 streams away from being accepted or being able to apply for the affiliate program. So I'm going to just do that the normal way, and then we'll see where we get to from there. But we don't need an X-Time macro in there anymore. We only need it just because I only want to write this horror once. And so this allows me to define it as an inline variable so that kind of everyone has actually reifies itself somewhere as a function pointer, and then I use the X macro again to resolve it automatically in the windowing code. So I kind of get double dip as it were from that, but there's no need to do it. It just makes my life a little bit easier. The import isn't automatic. You have to get proc address. Yeah, so I guess if anyone hasn't seen this before, then we do all that in Windows. We have a resolve global GL functions, and then it just uses the X macro here with this defined to resolve them. And this GL function here just calls wiggle get proc address. I know it's not wiggle, but that's how I choose to pronounce it. So it's all done. Did that a few streams ago. If you're interested, it's all available on YouTube if you want to go and watch those back. Get proc again. It's not get proc address is a Windows function, but you have to use the WGL get proc address specifically for OpenGL. I am using Windows H and WSL. I'll let someone. For those on Twitch, I cross compile everything with the Wine version of MSVC, so I kind of get access to all the Windows headers and everything, which is nice. Works for me. It works for me. It doesn't necessarily mean it has to work for everyone. Okay, so now GL get uniform. Nope, GL. What is it called? Why is this GL uniform? Thank you. All right. So the arguments to this are the location. I've got that. Nailed it. Swim uniform. The count, which I believe will be 1 because I'm only going to upload 1 matrix. Then, so this is interesting. These OpenGL functions have the transpose. So if you are using a library that is the different major order to what OpenGL is expecting, you can pass in the true flag there, and it will automatically transpose it on the way to the graphics card. But we don't need that because we are hopefully just going to, because I'm only really interested in supporting OpenGL, I'm just going to speak its language. It is unholy, but it works, and that's the best kind of code. And now I just need to whack in the data to the floats. There we go. So should now be able to do transform dot data, and then kind of horridly dot data again on the span. But what are you gonna do? The only reason I don't just pass through the raw pointer is because I feel it's better API designed to, if you're passing around raw pointers, is to at least send the size along with it. I feel like it's kind of good design if you have to do that. I guess I could have stuffed it all in a vector and then passed a const reference to that, but then it's a heap allocation. I don't really want a heap allocation per matrix. Okay, let's see if this blends, shall we? Yeah, I mean, If we have to inline assembly, then we've done it wrong, but we might have to. We'll see how it goes. I make no promises. We've definitely had to do inline assemblies on previous streams before, so we'll see how it goes. Yeah, library might be transposed just because that's just what they chose to do. Again, it's kind of convention how you treat those 16 floats, right? Do we think it's going to work? What do we think? I know the answer. I'm interested to see what other people's thoughts are. Do we think it works? What do we think we've got? Do we think we've... no, you can't do inline assembly in MSVC, you are correct. You have to write it in a separate assembly file and then link it in. That is a good point, yeah. I think you can't in x64. I think you can in 32-bit. There is some intricacy around inline assembly in MSVC. It's not really the thrust of today's stream, so also I can't quite remember the specifics, but I know there is some intricacy around it. It's either an absolute mess or it works as intended. Well, it's not a compiler error because it built and it ran. I do get a GL invalid operation error though. That's exciting. So what do we think? Do we think we've got black screen? Oh, do I have to bind the program before it? I mean, I'm going to tell you it works. I bet you're right. I bet you have to bind it before you use it, which means it's only errored once because on the next loop it's already bound because I never unbind it at the end and it works. We'll fix that now. That's a good spot. But yeah, nailed it. Transform matrix. Done. Easy. What could go wrong? Let's just fix that error. I think you are right. Let's bind this first and then do the transform misery. Let's just update my compile commands. What has happened here? There we go, and no error. So good spot there. Thank you very much. Appreciate it. What I really need to do is, again, it's kind of low on the to-do list, is when the OpenGL error reporter gets an error, like an actual error, it should throw an exception rather than just logging it. So it should have stopped us in our tracks. But hey ho, here we are. Right. What's exciting is that it's taken us an hour to move a triangle to the right, and I think that is the most productive use of an hour of my life. I hope you could all agree, and I'm glad you're here to experience it as well. So I translated it by half. So this, which was negative 0.5, was now 0, and this, which was negative 0.5, is now 1, I think. It doesn't really matter because this isn't like the end goal. We need to do more. We need to now start thinking about adding a camera in. So the idea is then we can move the camera back and forth, and then we need to do projection because that's just how this game works. So I am going to it's -1 to 1, so it's 2 by 2. That's correct. Good. Yeah. I will admit that I will copy and paste a little bit of code here, just because I can never quite. I've written my own projection matrix before, and I can never quite remember all the maths. And rather than spend hours debugging it, I'm just going to copy something that I know. Oh, actually, no, I might have to do it because I think when I did this before, I used row major, so I might have to we might have to move some stuff around. We'll see. So basically, what the plan is, I'm going to go back to Learn OpenGL because it is a great resource. Because what we're trying to do is coordinate systems. This is a great diagram, by the way. So what we've got at the moment is everything is in local space. So the model, the triangle, such that it is all the points are relative to its own local origin. It has no idea of anything else. That's why, they're sort of ones and minus half and half away from like the center. When we can times that, and then basically you have a series of matrix multiplications which kind of move it through almost like this pipeline of transformations, such that it ends up where you want it to be on the screen. So we first times it by the model matrix, which is effectively what we did there. That's its own internal transformation. That's moving it around and scaling and rotating it. And then we have the world space transformation. So it's the view one, and this you can kind of think to a certain extent it's like the camera, this is giving the whole world a local origin and then moving everything in relation to that. So if I move the camera like left and right, everything should move. What's kind of interesting about the way the maths works is that if you imagine, I don't know, you're looking at like an object through a camera. If you wanted to move the camera to the left, you would think, oh, I'll move the camera to the left. But the way the maths actually works is you actually move everything to the right and the camera stays still, which kind of sounds unintuitive, but it's just the way the maths works. The camera is effectively the origin, and so the transformation of the camera kind of applies to everything. And then we do the projection matrix, which gets us into clip space. So this is kind of like how it should actually look when rendered on a 2D plane. There's perspective, there's orthographic, that's on, and perspective. So basically how it handles like whether things have like a vanishing point as they go towards the center, towards the infinity or not. That's a good example. And then the rest of this crap, clip space and stuff, OpenGL just kind of handles for you. So what we're going to do now is going to try and add the view matrix and the projection matrix, which again should allow us to then move a camera around and have everything kind of look nice, and then we can kind of think about getting onto the cube. So we'll see how we get on. This is where I strongly suspect mistakes will creep in, but we'll see. Okay, so main. So I'm going to rename transform to model. And then we'll have view, and then we'll have projection. And then the order, I believe, is projection, because matrix multiplication is not commutative, so multiplying A by B it gives you a different answer to multiplying B by A. So this should give us all the parts we need to kind of have a full 3D world with a camera. And then we can add a camera class which encapsulates these two, pass that into the renderer rather than having it all hard-coded. That's kind of where we're getting to. Okay, right, so now we need to go back to our matrix class, and we need to add the functions which create these values. So if you look in a lot of like the literature, the view matrix is sometimes called like a look at matrix. The idea is that it's kind of like it's the matrix that creates the transformation such that the camera is looking at a certain place and angle. Where did I get to my knowledge encoding from? I mean, I went to a pretty reasonably standard kind of pathway. I did a CS degree, and then I did a master's, and then I went and got a job doing C++ for, and several jobs doing that for, I don't know, like 10 or so years. I've always been interested in graphics, but I've never done it professionally, so everything you're hearing me kind of like evangelize is stuff I've picked up myself, so there's almost certainly going to be a few mistakes, and I do apologize for that. I do try and get it right and do some research as I go along. Shaders are still a string in the code and not files, just because I've not written a way to load them from files yet. It's like it's on my to-do list, but kind of low at the moment because it's not needed. It doesn't drive us towards a game, and that's why I'm kind of keen on keeping the requirements like narrow. Like everything we should do should drive us towards making some sort of game. I did my degree at the University of Bristol. Great university. Well, I mean, it's the only one I've ever attended, so my sample size is 1, but from that, I think it's pretty good. Yeah, we might even get the pyramid spinning as well. Okay. Static. Const Explorer. I think I can have Const Explorer here. Matrix for look at, and this is going to take const vector 3 I, const vector 3 look at, and a const vector 3 up. So these are the three components to construct the view matrix, which you can kind of think about as representing your camera. It's going to have an initial position, so that's literally where your eye is in the 3D space. It's going to have the direction it's looking at, and then from there it's going to have the concept of up, because you can imagine like I could be stood here and looking over there, but which way is the camera rotated? So those are the three components you effectively need to create this view matrix. So my username Bags because I'm going to throw money, because people are going to throw money at me when I'm done. My username is Bags because it's my surname. But I appreciate the sentiment. Bristol is nice, lovely corner of the world. Okay, right, so I'm going... Let's see, I've got some notes somewhere on this before I start charging off blindly. Bring this back. Bear with me 1 second. So, from my previous work in this area, as in like my previous experimenting with this, I have this. So this won't work because I don't have any of these functions defined, which means we're going to have to go and define them all, so it's going to be a bit of extra work. However, what I suspect is that this is wrong because I think I did it in row major order, so I will need to just transform this, I guess, in my head to see if it works. So these vectors have to be normalized. Yes, I will normalize them as they're needed. Again, we could just make this a precondition of the function, be like, please only pass us a normalized vector, but there's no way of forcing that. So I'd rather just, for the amount of times we're going to call this, I'd rather just make sure it's normalized. Yeah, good point. Thank you. Okay, right. So what would we need? We need to do normalize, we need to do cross, and then we need to do subtraction, and then we need to do negation, and then we need to do matrix multiplication. There's quite a lot to do, and I'm not even convinced it's going to be right. So I guess we'll probably just start churning through this. I'll just check my notes, see if I can find what this is correct or not. But let's see if we can just build this up bit by bit. I suspect this is going to take most of the stream to do these primitives, but I think there's some fun stuff in there, so we'll see how we get on. So let's go back to our vector class. So we need const expra operator minus let's do minus equals first. Vector v1 const vector v2 vector ref auto, and then this should return. It should do v1.x minus equals v2.x yrz y excuse me rz, and then return v1. That's right. I've missed some threes. I'm sure someone's already seen it. Var dot. Yeah, so I think that's largely right, because then if you do it like this, then the non modifying one becomes a lot easier. This returns me a new one, and then I should be able to return vector 3. I should be able to return to 3 v1 minus equal v2. Why is that not liking that? Let's see if that. I don't know why it doesn't like that. There. Non-const ref. Maybe down to now value 24. Auto temp equals v1. Fine, whatever. Where else have I gone wrong? Normal. Oh yeah, it doesn't like that yet. So, but this is the bit I wanted to get to. This is kind of if you're creating these operator overloads, it's easy to do the modification one first, and then you can implement the other one in terms of that. So it's just like less coding. It's less chance of there being a mistake. How do I know? Oh, sorry, this is a good question here, and I missed it. How do I know what to put where? I'm assuming you mean in terms of OpenGL and programming. I mean, the C++ itself is just experience. I've been doing this for about a decade, so I kind of just have a reasonably good grasp of the syntax. I would not ever classify myself as an expert. I'm always learning new things. I always make mistakes. I always, I'm still trying to learn the language. In terms of OpenGL, I have some experience. I've written a game engine before in OpenGL, so I kind of have gone through a lot of this pain before, but that was quite a few years ago, so I've used this as an opportunity to relive that pain in front of a live audience because I thought it would be fun. Thank you, AC. I appreciate it, but I think there's only a handful of people who could really be considered a C++ expert, and I definitely am not. I'm definitely not one of them. Normalize. I think he thinks I'm just using this as a free function at the moment, so that's fine. So const expr auto normalize. There you go. Just keeping it with the British English there. Const vector 3 v. Does this return? This returns a new vector 3. So to normalize, you find the length and divide each member by it, right? I think that's right, isn't it? Vector normalize. Thanks. Yeah. So that would be then hash include cmath, right? So then I can get the const auto length by doing std hypot of v.x, v.y, v.z, and I should be able to turn .x equals v.x over length, .y equals v.y over length, and .z equals v.z over length. I think, right? I use AI quite a lot for coding. Copilot, I'm a big fan. I pay for it personally. I don't use it on stream because I think, well, if length is 0, then the whole world ends, and we'll figure that out when we get to it. But it's a good point. So std hypot is probably as fast, or if not faster than anything you would hand roll. So I think it's kind of good to use and good to know it's there. Well, there's lesser known functions. I use Copilot quite a lot. I find Copilot really good for When there's code I know how to write, and I just don't want to write it, then it will normally be pretty good at filling in. And because I knew how to write it, it's easy for me to kind of spot check that it was correct. I find that that is a good productivity tool. Doing something I'm not sure about, it can kind of go off on a tangent, and then I don't really know whether it's right or not. So yeah, that's kind of my view on that. But I disable it for the streams because no one's really here just to watch Copilot write all this, because Copilot will turn out, this is nothing here is particularly new or novel. Copilot will do a pretty good go at most of this, so it's much more fun to watch me struggle through it myself. So that should work. Have I namespaced it wrong? I bet. Have I namespaced it wrong? No, it's definitely in the namespace. Why is it complaining that this doesn't exist? I'm pretty sure I've got all the runes. Game normalize cannot result. Oh, because I've classified it as a free function, haven't I? Oh, what a fool. Stick this up here, and then make this static. There you go. Thank you if you saw that. Oh, So, hang on, I'll get to your question in a second, Adam. There's an important point here, and this is one of the things that really annoys me about using maths in C++, is that a lot of the maths functions cannot be const expr because of although std_hypot is new, a lot of like the old ones, they have a side effect. They set like no in the case of like a floating point error, so they can't be const expr. I believe there's a paper out to rectify this. But that means this cannot be that, which is a little bit annoying. I've just deleted the wrong one, haven't I? So I might change this, if I start adding more methods to this, I might change this to a class, because in my mind that fits better with my conceptual model. But yeah, it's kind of an annoying thing about const expr with maths. I started... CMath will be const expr in C++26. Nice. Like all of it. If it is nice, then we can go back and we can rewrite this code. Then that'd be great. I started programming when I was like 14 or 15, I think. PHP was my first language. PHP 4. So that tells you kind of where I am with things. Yeah, std_hypot is not const expr and doesn't look like it's going to be in... Oh, const expr since C++26. Got to wait a little bit longer, guys. A little bit longer, then we'll have a const expr hypot. I've been doing this a long time. By the way, I am not perfect. I'm not the best programmer in the world. I'm by far not even the best C++ dev at my company. What I kind of enjoy, and I think I'm half decent at, is explaining things, but I've still got a lot to learn myself, so yeah, I don't know if that provides some sort of context. Call the NSPC because no one should be exposed to PHP 4. Interesting, the way it kind of worked is that I was like, there's this thing called, I've heard of this thing called programming. Like, I have a computer and I've been told that, I've heard somewhere that I can do I can control it, right? So I went to the local library, and when I was like 14 or 15, and there were all the programming books on a shelf, and I picked one at random. That was it. That it could have been any language. It literally could have been any language. I just happened to pick PHP. I picked this one. exactly this one by Mike McGrath. Yeah, PHP in easy steps. This is what I checked out from the library, and that started my whole fascination with programming from there. So kind of funny, but PHP, what are you gonna do? Great language. Got a lot done in that. Learned a lot. I learned a lot. Looking forward to that short later. Yes. The AI tool I use to cut up shorts, I'm currently out of credits on, so when next month ticks over and I get some more credits, it's gonna be a great short that. HTML to C++ to PHP. Yep, it's an excellent progression. Okay, right. So now I should be able to do this. Should get this for freeze. Yeah, I started at 14 or 15. I can't remember exactly. It was quite some time ago, over half my age ago. Okay, so now cross. There's a lot going on here, and for some reason I used a member function. So I'm just gonna fix this up to be normalized. Just keep these nice as like static functions. So I now need to do cross, which means I have to remember how to do cross. 3. I might tidy this up later and make this a class. We'll see how it goes. It doesn't drive us any closer to the goal now. So, and that's going to take const vector v1, const vector v2. Although I might. Oh Jesus, where's that? Where's my code gone? I might just declare these hit and define them at the bottom just to keep it cleaner, but we'll see how we get on. Yeah, should alias that. Right, okay. I'm just going to look up how I did vector cross in my old code. 3 cross is that. Someone's saying line 16. I've already fixed it, or have I missed something else? Whereas .low, don't need it. Only implementing things I need. This is bare bones. This is minimal. This is not writing any code unless I have to. So let's copy this, because I'm pretty sure this works. I seem to remember doing this in A-level further maths. Could even be real maths, this. Am I going to need a temporary? In fact, actually, what am I doing? That's even easier than that, isn't it? Dot x equals I, dot y equals minus j, obviously, and dot z equals k, obviously. Could even be maths. Someone's pointing out some code. Vin says v1.x times v2. Is that a typo? Oh, okay. Could even work. Could even work. No, is it wrong? I'm pretty sure. What does that mean of crossing a vector? Like, it gives you the angle between the vectors. Cross product. Here you go. Yeah. Cross product is a binary operation of two vectors in a three-dimensional space. Blah 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 blah. Both. Oh no, it gives you one that's perpendicular to both. That's it. The dot product gives you the angle. So given A and B, it will give you one that is perpendicular to both of them. Given two linearly independent vectors A and B, the cross product is a vector that is perpendicular to both A and B and thus normal to the plane containing them. That's it. Obviously. I don't know why I keep missing off. I think because I'm so used to typing stood vector, in my mind, it's there's not very often I need to append a number to it. Dot product is cos theta, yeah. Alright, okay, fine. We're getting there. Making a mess at the moment, but ideally we're going to end up making a simple 3D game from scratch. So now I need back to vector because I can see it coming up. I need const expra auto operator minus const vector b to give a vector reference. Nope. And this will return v minus v dot x minus v dot y minus v dot z. So this should be the unary operator, the unary negate operator. Yes, I know I've missed the 3. I know I missed the 3. So I should be able to negate a vector by just sticking a minus sign before it. I can't make these const expra. Oh, I can make this one const expra. But I can't make this one const expra because stood hypot is not const expra to C plus 26. Yeah. Okay, right. I hope everyone this is how they thought they were going to spend their Sunday evening or whatever time it is for you going through linear algebra with me. I'm glad you're here. What my thoughts on a header like GLM are? My thoughts are you should absolutely use it rather than going through this misery, but here we are. Okay, so I think I'm nearly there. So now I just need to check whether this is correct. Which I don't think it is. I'm just trying to find some notes on this. So SXS, there almost certainly is a better way of doing it. I'm just looking at how I did it before, and I think I did it on pen and paper from how I was taught at school. So we can look at optimizing that later. You didn't think I was going to spend this evening talking this much instead of coding. I kind of had a suspicion because I've not been feeling that well, so I thought actually I might end up padding it out a bit. But anyway, apologies if I'm waffling too much. This is where we're at. What time is it in Tennessee? I'm keen to know. Do tell me. Do tell. Okay, found something somewhere which suggests where these. I wonder if I should just transpose this because I'm pretty sure I wrote this for row major. Let me see if I can find my notes on where I know when I did this before. Constructs a new matrix with the supplied row major values. Okay, so fine. All I need to do is just all I need to do is just transpose this then. So s.x u.x minus f dot x 0.0x 0.0f, and then s dot y. Hang on, am I doing this right? U dot y. Hang on, so this goes here. This thing goes here. Yeah. Minus f dot y 0.0f, and then s dot z u dot z minus f dot z 0.0f, and then 0.0f 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 1.0f, and then goodbye. Hope that was right. Could even be right. Could even be right. Now I need to just do matrix multiplication. So I thought const expr functions should be evaluated at compile time. How are you going to make these const expr if the arguments aren't known at runtime? That's such a great question and such a interesting insight, because like I think about this a lot. Like, what is the point of doing all this const expr stuff if at some point it's going to need runtime data? What's the fucking point, I guess, is the actual kind of question. And for me, the kind of realization I came to is that you don't really know what the compiler is going to do, but the more hints you can give it about stuff it can do at compile time, the more likely it is to find out patterns and do it. So by making stuff const expr when it can be, you're kind of just giving the compiler more ammunition to make faster code. It doesn't mean your entire program will be compile time, will be boiled down to like a single const expr expression and then evaluated, and just like the value appears. So yeah, that's kind of my view, is that I think it's kind of good practice to give the compiler as much information as possible. If you treat your compiler kindly, it will treat you kindly back. So yeah, it might be that there's just somewhere that the compiler can now that it has this, can be like, oh yeah, I can just do that at compile time, because it knows all the inputs, it can see the whole system, right? But without doing that, it wouldn't be able to do it. Is this going to percolate through? Because yes, you're right, this can't be const expr. That's such a good spot and really annoying. This auto is italicized because that is just how this is set up. I've not once told it to, and I've not even noticed it until you said it. So now I will always see it. So thank you for that. Okay, so matrix multiplication. I'm sure for anyone who is an expert in implementing maths libraries, there's almost certainly a better way to do it than I'm about to do it, because I'm literally going to do it the textbook's way of first row by first column, second row by second column, etc., etc. Auto operator star equals matrix for M1 const matrix for M2, returning a matrix for ref, and this will at the end of it return M1. Okay. Have I got some code that already does this, or am I going to have to? You're going to have to sit there and watch me type it all out, because that is painful. Well, I'm hoping, like, obviously SIMD will be, I'm hoping that even if I just do it the textbook way, SIMD will still kick in and figure it out. But yeah, I'm sure there's better ways of aligning it to that. So I have some code that does this, but what I'm concerned is that because it's row major, it will technically be wrong. Because I need to do, let's have a think about this. Thanks. So you got 0, 1, 2, 3, 4, 5, 6, 4, 5, fuck's sake, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's so you got to do first row by first column, but it's column major order. So I actually have to do first column by first row, right? That's right, isn't it? Because you hang on, I'm gonna try something. I might actually. See if Copilot can figure this out, because this is a lot of. Can I just prompt it? Multiply M1 by M2 column major. Okay. Is that right? Is that right? I'm not convinced. It's gonna go. So I and J are gonna run through the elements, and then it's gonna say for each you take the current element and add. See, I'm more about this add to, because you have to be careful when doing matrix multiplication that you don't cache early values. Oh no. Would this work because you're using a temporary? Because effectively what you're going to do, basically this is the only thing we care about. This bit here is correct in the sense that it will loop through all 16 elements. So what I'm going to say is, yeah, that's a good point. We could just run this and check. That's such a great point. Thank you. Sometimes you kind of get lost in the weeds of it. I will have to make this a friend operator though, because it needs access to the internals. How do we want to do this? Either is provide a constructor. I think the correct answer is to actually provide a constructor. What's going on? Which takes I guess it could be a stud. Alright, Copilot, go away now. Const stud array of float 16u called elements, and pass that into our elements. So I can actually construct a new matrix with arbitrary data. I think that's right. Yeah, and then I can use span to pull out the actual data. Yes, I think that's right. So so result actually becomes stud array float 16u result. I don't really like result, but oh no, because I need to set the data, don't I? That's the problem, because it has to mutate it. So actually now, by doing this, I do actually need to provide a way of mutating the data, which is a little bit annoying. So I will have to make it a friend function. It's not the end of the world. We can handle this. So what am I doing? I'm going to do up here, going to do friend Sexborough, which should give me access to the internals, and then m1, then I need to do m1 dot elements equals, I should just do m1 equals result, because I think I will get a default, should get a default copy constructor. I can't return result because the whole point of the star equals operator is that it mutates the first element, so I still have to effectively return that, otherwise you'll kind of break the precondition that you are mutating the first element. Okay, I mean that's about as good as it's going to get, I think. I'll tell you what we do need to do, and we've not done this for any of the classes, which is a bit of a pain, is... can anyone remember where we added custom logging format? Where did we do this for shader? So in outside of the namespace, hash include... Oh, loads of, sorry, I've been lost my own little world there, and loads of messages come in. Apologies. If I do, yes, I do need star operator, but I want to implement it in terms of star equals operator because it might not seem it will actually be slightly less code. So this is game matrix 4, and then game matrix 4. I don't need any of this because then I just need. Do need one of these. And then this is going to be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Const auto data equals obj dot data dot data, and now we can do data not 2, 4. It's actually now easier for me just to do it manually. 8, 9, 0, 1, 2, 3, 4, 5. So there. Spaces after 2\m will be missing. Yes, thank you. And I don't want them anyway. Okay, right, okay. Whew, now we've gone through that. So now we can do, the first thing we can do is do, so game matrix 4 m1 1.0 f 2.0 f 2.0 f 4.0 f. And then R2, and then do M1 times equals M2, and then stood println. This is where the whole thing goes bang, but we'll see what happens. Right, okay. You don't need the point f if it has no decimal. No, you don't. But I just, for consistency, I just always do it. So that's just a personal preference of mine. I'm running, what graphics card have I got? I got a 3070, I think. What do we reckon? What do we reckon? Could even be right. So let's do 1, 2, 3, 4. Two, 3, 4 times. I probably should pick some different numbers rather than repeating rows because I suspect that might hide some subtle bug. But I mean, Wolfram agrees that this is indeed that. But my concern is because it's column. I guess it doesn't really matter if it's column major as long as it's. Because if I transpose them both, I'll get the same thing. However, you know what? I remain hesitant, but we'll see what happens. Okay. Let's leave. We'll leave that in there for future warring. Right. Okay. Anyway, back to Matrix because we're getting there. Right. Okay. So friend context with revert. So now I can do this, and this will return this, and this will be const like this, and then I can go down. In fact, I think this. Ooh, this no longer needs to be a friend, which is exciting. Just take that. Stick that in here, and then context report, and then just mash my keyboard and get a load around keystrokes. Auto temp M1 return M1 times equals M2. Pretty sure that does exist. Pretty sure it does. Because yeah, I think it could be a double transpose bug, but we will see. Uncle Google says row or column major does not matter for multiplication. I feel like I don't want to keep using this as an excuse, but if I didn't quite feel quite so rough, I could probably work through the maths, at least maybe not in front of 100 people, but on pen and paper. Whatever. Here we are. We're here. We're going for it. Okay, right. So now back to the thing I was trying to do originally, which is now allows me to return this. I don't have make translate because I've actually just put it in the constructor. And question mark. So I've just implemented a frame buffer into my engine and couldn't figure out why it was showing a black screen. Took a whole day to find out. I forgot to bind the texture of the primitives. Happens to us all. I feel your pain. It almost certainly happened to us at some point live on stream, and then you won't have the stress of loads of people all staring at you, judging. But I'm glad you got it sorted. Binary star game matrix does not define this operator or a conversion to a type acceptable to the predefined operator. Pretty sure it does. Unless I'm thinking what I think the issue is, it because I've specified these as free functions down the bottom, and so at this point when this is being compiled it doesn't know that those definitions exist. Like, so no, but then I can't. No, that can't be right because otherwise I can't define them before because I haven't defined the matrix class yet. Have I got a bug? Has someone saying line 74? Am I being stupid? Because what I will do then is, for the avoidance of doubt, what I'll do is I'll drop this down here, remove this auto, make it part of the... What I should do is just move this to a CPP file, which I will probably do later, because it's not const expra, so in my mind it should live there. Yeah, okay, fine. I think this will work, but I'll move it to a CPP file later. Yeah, fine. Okay, yeah. It just didn't have full insight into all the bits it needed to actually execute it. I don't really want to forward declaring all the operators and stuff. Like Bin says, you are right. That was the problem. I think I can just make this better by just using a CPP file. The only reason I'm not using a CPP file is because I want const expra, which I think has to be in the header files. Okay, fine. Let's see where we're at. I'm probably not, might not have time to do the projection matrix today, but let's at least see if we can wire up. I don't even know what it means to kind of render up with just the view matrix, but we'll see what we get to. So let's copy and paste more code, because that's what we're all about. Let's take a step back, right. Let's change this to model. Okay. And then we're going to do model view. Let's just go to all the models, so CFL view, view, and then this one will be proj, and then CFL proj, and then proj, and then proj, and proj. Okay, so this I'm going to just leave as the identity matrix for the moment, and then this here will be matrix for... Now, here's the classic problem is I'm going to construct a lookout matrix where I think I'm going to put the camera in the right place, but there's always the chance that I put it in the wrong place, and the maths being broken and me just pointing the camera into the void as largely indistinguishable. So you have to. So there's an interesting point here. You have to be really careful with return brackets, because this now, oh my goodness, becomes an expression. So it's a really niche case that there's a really niche issue that this can cause, and I think your compiler will warn you. But if you have decal type auto foo, oh my goodness, int x return x, due to the way the type deduction works for decal type auto and the fact that you've now made this into an expression, this will actually return an L value reference to your stack variable. And this will effectively be undefined behavior. So if you're writing this a lot, I would definitely recommend you don't use the braces, but because of that, return is not a function, it's a keyword, so personally I don't put it in the brackets. Yeah, little C++ insight in for you. Yeah, so you're right, the camera needs to be moved back. So look at, I can't remember what my arguments were now, I think it's I. look at. Okay, fine. So the I, so this will be dot x equals dot y. Let's keep it 0 because I think it's easier. 0f dot y equals 0f, and then dot z will be, I need to move this plus 1.0, right? Because the negative right hand x, y, z, the positive axis is coming in away from the screen, so I need to move the camera back. I will look at the origin. Oh my goodness. Too many, way too many commas in this. And then the up will just be positive y. I might have to add some vector constructors. You know what, I'm gonna improve things as I go along. I will add a vector 3. Oh no, because then that will remove the ability for me to get the designated initializer. Fine, I'll just do it manually to start with. We'll keep it. Sorry, I think I just rambled for a bit there. I don't even know if what I said actually was in any way legible. Sorry, loads of stuff just came in. I'm just checking it all. If you want to make a compilation of look, here's a great point for you, Moose. Right, if you want to make a compilation of all the times that I make a typo during stream, you should just watch the stream because they will be largely indistinguishable. I think people are arguing over my. Oh, can look at not be context, bro. Damn it. Using Z up coordinate system or a wrong? No, but does this is my code? Is this wrong? Yeah, Y is up. So it's the right hand coordinate system. So your thumb goes along the positive X, your index finger goes along the positive Y, and then your ring finger goes, therefore, points on positive Z. I don't know. Could even work. Could even work. There's not left a lot of time for debugging today, so I hope it just works. Let's reset the transform matrix. Right, let's. Okay, so that's not working for me. Let's see if render doc helps at all. Hang on. Right. CP HR.2 and C game. Okay. File. Nope. Executable path. Let's find this. Let's move that off the screen. Downloads game source game. Okay. Let's allow vsync, collect call stacks, enable API validation, capture command lists, not that I'm using any. Okay, fine. Let's see if this works. Okay. capture one of those, escape out. Yeah, I suspect there's a bug in the transpose matrix. So if no one's ever used RenderDoc before, it is a way of debugging graphics programs. It works with Metal, DirectX 12, DirectX 11, OpenGL, a load of stuff. So I can basically capture what the game is rendering, which is absolutely sweet FA. But we can see our calls here, so we can see the draw calls. What I want to see is the matrix that I've given it. How do I do that? I can never remember how this actually works though. So I've got my shape. Right. Pipeline state, vertex shader. So this is my program. Uniforms, 3 variables, go. Okay. So the model is the identity matrix. The projection is, oh, interesting. Okay, so there's definitely a bug here because the projection matrix should be the identity matrix, which is not. Yeah, but I set the projection matrix to the identity matrix, so it shouldn't make a difference, right? The name of projection is wrong on my code. Oh, it sounds like there's lots to unpack here. And this could even be right. It's probably not, but it could even be right. So let's have a look. What's? Oh, yes, you're right. Thank you. Glad someone's paying attention out there. Nope, just copy that somewhere. We will be using RenderDoc a lot. Boom. Typo. Maths is right. English is wrong. Okay, right. Let's just see then if I can move the camera. Like, if I... Can I move the camera to the right? If this works, then I'm kind of happy to wrap it up here and we can do the projection next time and maybe something a little more interesting. Because once we've got that done, like, we are very close to being able to render, like, it unlocks all the other stuff, right? Because we can have a camera, we can add some camera controls, we can fly around 3D space. I mean, I think I'm going to suggest that I probably need the projection matrix at this point, or there's a bug in it. Triangle should be to the left, yes. The default screen location is bugging me, yes, but I don't care enough to fix it. Let's have a quick look at the... Can you... No, never mind. Yeah, it's been clipped. Interesting. Problem is that I don't... The view might have rotated. It's impossible to say. The problem is that because I don't have all the pieces there, we are just guessing, right? There's almost certainly a bug in this. Well, that's like, it's impossible for me to know with the information I have here and my limited sort of like understanding of this all, whether this is the bug, or the bug is because we don't have this set. Like, I don't know. I don't have that deeper understanding of the OpenGL matrix like intricacies to be able to say which is true. We could, so I think, just looking at the time, yeah, I think you're right. I think Jason's right. I think we need the projection matrix. So what I'm going to do is, because this is about the time I normally end, I've had a quick look at the perspective projection matrix I've used before and works. I'm just going to quickly slap that in and just see if it works. If it doesn't work, problem for next stream. and then I'll definitely fix up all these into CPP files. Perspective. This should be stood. I don't know why I did that. Okay, so blah, blah, blah. Again, this will need to be transposed super quick. Yeah, the clip space is wrong. Okay, yeah, okay, fine. That makes sense. That makes sense. Okay, so I think now I just need to, again, I did this for row major, so 3, 1, 2, 3, 1, 2, 3. Okay, so now all I need to do is super quick. Copy this. 2. Oh my Jesus. Right. Okay. 2.0. Keep a close eye because this is prime typo territory. If you're interested in what this actually does, then all the maths is kind of like available online. I just looked it up. I just found an article and just read through it all. Oh Christ! R plus L over R minus okay, so T plus B, T minus B, and then alright, Christ, far plane plus near plane over far plane minus near plane, obviously. What else would it be? It'd be silly to have anything else. Minus 1.0f, got up to minus 1.0f in there. And then finally 0.0f minus 2.0f times far plane times near plane over far plane minus near plane. And finally 0.0f. I mean, what could go wrong? Okay. Looks good to you. Brilliant. Thanks. I don't know if that was. I don't know if you checked that or if it's mild sarcasm. Either way, I'm glad we're all on board. Okay, fine. So matrix for perspective. So I want 45 degrees. So that's pi over 2. Where's pi? Where's pi? I can never remember which header it's in. And in the numbers. Thank you. Oh, what happened there? Hash include numbers. So stood numbers pi over 2.0f, and then the width is 800.0f. Like, we will definitely end up not. We will make sure these don't get hard coded later. An F, and then what do I want for the near plane? Like, is it like minus 1.0 f and then like 100.0 f? Is that right? Does that make sense? Pi over 4. Thank you. Yep. I can't remember if I want my near plane to be 0 or slightly in front of me or slightly behind me. The far can't be negative. Okay, so it's got to be 0. Yeah. And it should be const. Correct. Close to 0. It's pretty close. Where have I truncated from a... oh, is it? I bet it's this. I bet I need to do it. Is it? Obviously. So C++ 14 introduced templated variables, so you can actually have a variable that is a template. So pi is like the classic example of it. So you can say, can you please give me pi as a double or a float or whatever, and it defaults to double. So that's what that error was. Sorry, I just quickly just sort of saw it, recognised it, and fixed it. I think pi is if it is defined, I don't know whether they defined all the types, it'd be 3. Yeah, not quite right, but close. Like, I think I just need to quietly go through and fix all these. I wonder if we pull the camera back like quite a bit more and then not move it. I think it's good enough for today. What I try not to, my aim is to not do anything off stream and commit it, but what I might do is just play around with the matrices just to kind of figure out what the understanding is, and then I can debug it with you guys live on Wednesday. I don't know. I mean, pretty good. It's pretty good if you put it back a bit. So what was if we shift the camera to the right? Yeah, something's not quite right. It's definitely you can see it's where the aliasing artifacts are. It's actually slightly rotated. Anyway, I think that's absolutely good enough for today. Let's just have a quick look at where we are with the code. Class commit add vector 3 class matrix 4 commit add matrix 4 class. Not gonna commit that because it's just a bunch of mess. Commit add vertex data. I know these are structs, but I've typed that now. So in mesh we what am I doing? Commit integrate vertex data with mesh, and then with, I'm going to say with all of these we basically commit start to integrate model view projection matrix. Oh yeah, so that's a good point. Let's super quickly do this. Someone pointed out something I missed last time. Do you WGG25? Do you know what the magic rune is? I was going to have to look it up quickly. OpenGL. Let's have a look. And what I'm talking about will make sense in a second. Here we go. Right. Okay. Fine. So let's go to window. So we have set up a OpenGL debugger, as in, sorry, we've registered a callback for the OpenGL debug function. So it will just call that when there's stuff that it wants to send us. My understanding is that the point at which it writes out is kind of left up to OpenGL. However, if we just slap this in, then this will synchronize the debugging with the function call. So whilst it might make the code a bit slower, we're guaranteed that once a function is called, if there's any error messaging, it will be printed out at that point. And I believe then, if we then like print a stack trace or throw an exception, it'll make it much easier for us to tie up any OpenGL errors we have to the code that we wrote. And let's face it, there's going to be quite a lot of OpenGL errors we write, so that's useful. Let me just commit that. So boom, commit. I've broken my tooling again. Right, commit. Sync OpenGL debug log. Debug log, and then let's go for tag. No. How do I tag? Uppercase T, of course. For tag, and then this has been stream 5? Is it stream 5? Stream 5. Someone's already said it. They already knew. Thanks, Steve. You already knew what I was going to ask because you already knew I'd forgotten. Thank you. I appreciate it. Did this exact same thing last time. So yeah, what I'm going to do is I will not commit anything, but I might have a little play around with it before Wednesday, just to kind of double check to myself that the maths is correct. Put the stream number in the title next time. So there's a whole kind of thing around the YouTube meta of not putting like episode numbers in things because it's off-putting to people who have not seen any of the previous ones. So by not putting them in, I hopefully encourage more people to want to come along and find out what's going on. It's a bit strange. It's kind of the game you have to play on YouTube. So I do apologise for that. Anyway, I feel rough. I'm going to have a beer. I'm going to go to bed. Thank you very much for everyone coming along. I greatly appreciate it. And I will hopefully see you all on Wednesday. Thanks very much.